Hello and welcome to the Unit 10 review. In Unit 10 we're talking all about polynomials. And so let's go ahead and look at some of the problems that might be on the test. So for the first section here we are writing the following polynomial in standard form and then classifying it by degree and number of terms. Okay. Let's go ahead and look at, we'll look at number 2. I think it's probably, one of the harder ones in here, but that's okay. So the highest exponent on the variable is the third power, and then the next highest one would be the first power, so plus 10k, and then no variable goes last always. Okay, so minus 7 there. So we have 5k cubed plus 10k minus 7, and again we have a cubic here because it's the third degree. And it's a trinomial because there's 3 terms. So cubic, trinomial. And that's going to be our answer for that one. All right, let's look at the next section here. There's a bunch of sections that we did as the unit went along that were kind of combining into the same group of problems here, and it's really all about simplifying polynomials. We have add, subtract, and really just multiply for us. So let's go ahead and look at a couple of them. I'm going to go ahead and start off with one of the subtraction ones because I do think they're a little bit harder. Remember, if we have subtraction, what we really want to do is write down the first one. Oh, that's a 5k squared. And then distribute that negative into every term in the second polynomial. So that'll be a minus 4k, a minus 8, and a plus 3k cubed. Now all I really want to do is write it in standard form and I'll be done. So the highest power on the variable k is cubed, so that's going to be 3. We'll say these are equal. So 3k cubed. I'm going to go ahead and cross that one off. Next one would be k squared, so that's going to be 5k squared. Cross that one off. I do have like terms in the k's. I have plus 3 and minus 4, so that'll be a minus 1k. Can cross those off. And then I have a plus 1 and a minus 8, which will leave me with minus 7. And I can cross those off if I wish. So that'll be my answer right there, written in standard form. Always the way you should answer any sort of polynomial questions. In the next couple problems down here, we're dealing with distributing. Okay, I want to go ahead and look at number 11. So it's not the easiest, but it's definitely not the hardest either. Really, what I'm doing here is I'm multiplying 2 polynomials. This first one just happens to be a monomial, and the second one is a binomial. So I'm going to multiply those two together. 4 times 3 is 12. X times x is x squared. 4 times negative 5 is negative 20. X times really 1 is just going to make that a 20x. And that's my answer. Okay. I'm going to go ahead and leave the next two for you, but if you remember, you need to FOIL or we kind of saw it as double distribute. Okay, I'm leaving these because I'm going to do one of the harder ones. I like those ones a little bit better. Let's go ahead and turn the page. So there's some more problems just like that on the back side here, or the second page, I guess. I want to go ahead and look at one of the binomial times trinomial because those are a little more exciting. I'm going to look at number 18. So the idea here is that I want to multiply everything in the first polynomial by everything in the second. So I'm going to start with a 3n. So 3n times 7, well, 3 times 7 is 21. N times n squared is n cubed. Let's move on. 3 times 3 is 9. N times n is n squared. 3 times 8 is 24. And there's just an n there. On my next row here, I'm going to be distributing a negative 5 to everything in that one. I'm going to go ahead and stack them up to where I can simplify it a little bit easier. So negative 5 times 7. Well, I look at what the term would be. It's going to be an n squared term, so it's going to go right here. Negative 5 times 7 will be a negative 35, and that'll be n squared. Negative 5 times 3 is a negative 15. Negative 15, and that'll be an n term. And then negative 5 times 8 will be minus 40. Now I can just add up my columns here. That's why I write it this way. It does make life a little bit easier. So we get 21n cubed. 9 minus 35 is going to be 24. Or sorry, that's a negative. So that's going to be a negative 26. And those will be n squareds. And 24 minus 15, that's going to be a 9n. It'll be a positive. And minus 40. So that's what we get there. Okay? And so I'll leave the rest of those to you. They're a lot of fun. And just make sure you multiply everything in one by everything in the other. The next section here, we are factoring out greatest common factors. All right, there's plenty of problems here to pick from. I'm going to go ahead and look at 24. Okay, I want to leave some of the harder ones for you, but if I'm looking at 24, I think the greatest common factor of the integers is going to be a 6. So we'll pull out a 6, and it looks like everyone has at least an r squared. Okay, so when I go 60 divided by 6, that's going to be 10, and that's going to leave an r cubed. And 18 divided by 6, that'll be a negative 3. That looks like it's just going to leave an r. And 48 divided by 6 is 8. And there's no r's there because we pulled them all out. And that's what we get. Okay. Let's go ahead and look at the next section. We're going to be factoring polynomials now. Okay, and this is where we're turning a trinomial into a pair of binomials. I'll do one of these because they're a little bit easier. The coefficient on the squared term is 1. Okay, and if you remember, we're looking for our key numbers. I'm starting with whatever this term is in each one. Okay, so it's going to be an r and an r. So now I need two numbers that multiply to a times c. In this case, that's 12. And I need to add to b. And b is 8. So, at this point, you can't see that, but at this point we should be getting a little bit better at this, maybe be able to pick out the numbers a little bit quicker. But two numbers that multiply to give me 12, and then add to 8. Maybe we're looking at 6 and 2. Okay, because 6 plus 2 is 8. So let's say we have plus 6 plus 2. Remember, for the Australian method, we're dividing this by the number in front of r. It's just 1 now, so our final answer will be r plus 6, r plus 2. Okay? Hopefully you're getting a little bit better and quicker at those problems. Let's go ahead and look at the next page. So over here we have some more complicated factoring problems. And I'll go ahead and do number 31. That looks like a good one to work on. So for number 31, I'm just going to say multiply to 10 times 5, which is 50, and add to negative 27. So what numbers multiply to give me 50 and add to 27? Well, I'm thinking that we're probably going to have like a negative 25 and a negative 2. Because when you multiply those together, it gives you 50. When you add them, it gives you a negative 27. Okay. So remember, we put that 10 in the front of each one of these. So 10x let's say minus 25, and 10x minus 2. And remember, we are dividing that by 10. Okay. Now the next step, factor out any common factors that you have. So this one looks like they both have a factor of 5. So I get, oh, not 10, 2x minus 5. These ones both have a factor of 2. And so it's going to be 5x minus 1. And then when we divide that by 10, the 10 cancels with the 2 and the 5, because 2 times 5 is 10. So that's what we wanted, is we wanted that number down there to cancel out. So we're just left with the numbers in parentheses, 2x minus 5 and 5x minus 1. Okay, so there we go. The next two problems are not 32, but 33 and 34. Those are differences of squares. I'm going to go ahead and leave those for you. But down below here, we are solving by factoring. We're going to use factoring to solve these equations. And really what you're looking at doing is the same thing. I'm going to go ahead and do number 36, and then I'll leave the rest of them for you. First step is to get everything on one side and 0 on the other side. So that'll be p squared plus 5p plus 4 equals 0. So I can kind of think over here. I want to multiply to 4 and add to 5. Okay, multiply to 4, add to 5. I think that's 4 and 1. 4 plus 1 is 5. So there we go. Since the number in front of p squared is 1, I'm not even going to write the fraction there, but we get p plus 4 and p plus 1 equals 0. So in order for this whole thing to be 0, either this part has to be 0 or this part has to be 0. So either p plus 4 equals 0 or p plus 1 equals 0. And then, you subtract 4. So either p is negative 4, or if we subtract 1, p is negative 1. So use your factoring skills to solve those problems. Okay? Let's go ahead and turn the page and look at the next set of problems. So here we have our applications. All right? And again, just like always, I'm not actually going to do the problems. I'll help you set them up, and then you get to do them. Okay? So here it says use the rectangle at the right for the following problems. Find the perimeter of the rectangle. Well, the perimeter equals 2 length plus 2 width. It's probably the easiest way to do it here. So really you're just going to plug in your length and width into those spots and simplify. To find the area, that's going to be length times width. So you're just going to multiply those two binomials together. Okay? Now, for the next part, suppose the area is 45 square inches, and they want you to find the dimensions of the rectangle. So here's the important part. So length times width equals 45. Okay, that's the area. And you should know what this part is by now, if you've done the problems before. So what you're going to want to do is you're going to want to go length times width minus 45 equals 0. And so whatever constant term you have on the length times width, you're just going to subtract 45 from that. Now you have 0 on the right, everything else on the other. And then you want to factor. Okay, when you factor, then you can solve for h. Okay, but it does say to find the dimensions of the rectangle. Once you solve for h, you need to plug it back in for h in these two spots to actually figure out what the length and what the width is of this rectangle. Okay, not too bad, but there's some parts there that trick people. A lot of people think, well, I found h, I must be done. Not quite. Okay, let's go ahead and look at the next problem. So the next problem says a projectile is an object. Yeah, we've talked about that before. Okay. Let's go right here. This is the important part. So your friend throws a ball from the roof of the NBHS administration building, which is 80 feet in the air. Excuse me. And it has an initial velocity of 64 feet per second. So that's going to go in for this V. All right, that's where that 64 will go. And then the initial height, the 80 feet, will go in for that H. Okay, so those two numbers are important to the problem. Okay, and that's where they go. Once you do that, you're just writing that equation. All right, that's what's going to go right here. And then how long until the ball hits the ground, that's where you're looking for, sorry, not T, but H equals 0. So what you're going to end up doing is, sorry, not H. The height would be 0, yes, but in this case it's S of T equals 0. Okay, so set the left-hand side here equal to 0, and then you'll factor and solve. All right, so good job on this. Make sure you get this stuff done and checked off, and then good luck on the test. We'll see you next unit. See ya.